The amount of space an object takes up, volume. Volume is the measure of how much space an object occupies. Imagine trying to fit all your groceries into a single shopping bag at the checkout line. This challenge is similar to understanding volume, where you need to figure out how much space all your items will take up inside the bag. Just like how you must consider the size and shape of each grocery item to see if they fit together in the bag without overflowing, volume measures how much space an object occupies, determining whether everything can be contained within a limited space. The amount of matter in an object, mass. Mass is how much stuff or matter is inside an object, determining how heavy it feels. Imagine you're packing a suitcase for a vacation, trying to decide how much you can fit inside. Just like you assess the contents of your suitcase to determine if it's over the airline's weight limit, mass measures the amount of matter within an object. The weight of your packed suitcase represents its mass. Every item you add is like adding more matter, increasing the suitcase's mass, just as each particle contributes to an object's total mass. Anything that has volume and mass. Matter. Matter is anything that takes up space and has weight. Imagine trying to fit all your groceries into a single small shopping bag. Just like how each grocery item takes up space and adds weight to the bag, matter is anything that occupies space and has mass. The groceries represent different types of matter, each with its volume, space it takes up in the bag, and mass, how heavy it makes the bag, illustrating how matter is essentially everything that has volume and mass. Measure of the force of gravity on an object, weight. Weight is how much gravity pulls on an object. Imagine you're trying to carry a backpack filled with groceries up a flight of stairs. Just like how the backpack feels heavier depending on how many items you pack into it, the weight of an object is essentially how much the Earth's gravity is pulling it down. In both cases, the heaviness you feel is a direct result of an external force acting on the mass you're trying to lift. Whether it's the force of gravity on the groceries or the strain on your arms as you climb the stairs. A physical change of matter between solid, liquid, and gas. Change of state. It is when matter changes from one form to another, like ice melting into water. Have you ever tried to decide what clothes to wear when the weather keeps changing unexpectedly? This is similar to how matter changes between solid, liquid, and gas, adapting to different conditions just like you adapt your wardrobe to the weather. Just as you might switch from a coat to a t-shirt as the temperature rises, matter transitions from solid to liquid to gas as energy heat is added, with each state being like a different outfit suitable for the prevailing conditions. The temperature at which a solid changes into a liquid. Melting point. It is the specific temperature where a solid turns into a liquid. Imagine trying to remove a stubborn, stuck jar lid that won't budge no matter how hard you twist. Just like how applying the right amount of heat can loosen the lid, reaching the melting point provides the energy needed for a solid's rigid structure to weaken and flow into a liquid state. In both scenarios, a threshold is met, twisting force for the jar and temperature for the solid, allowing for a transition from a fixed, unyielding state to a more flexible one. The top of liquid changing into a gas. Evaporation. Evaporation is when a liquid turns into a gas, usually from the surface, when heat causes its molecules to move faster and break away. Imagine sitting in a crowded room, and gradually people start leaving one by one, making the room feel less congested. This is similar to how molecules at the surface of a liquid gain enough energy to escape into the air as gas, reducing the overall density of the liquid at the top. Just like people leaving a crowded room makes it less crowded, molecules escaping from the surface of a liquid into the air make the liquid level decrease, illustrating the process of evaporation. The temperature at which a liquid boils. Boiling point. The boiling point is the temperature at which a liquid changes to a gas. Imagine trying to find the right moment to leave a crowded party when it becomes too overwhelming. Just like waiting for that perfect moment to step out, a liquid waits until it reaches a specific temperature to start boiling. The connection lies in the buildup. At a party, it's the growing noise and energy that signal the need to leave, while for a liquid, it's the accumulating heat and energy that causes it to transition from a liquid to a gas, reaching its boiling point. The temperature at which a liquid changes to a solid. Freezing point. It's the specific temperature where a liquid turns into a solid. Imagine you're juggling multiple tasks at work and suddenly everything comes to a standstill when your computer crashes. This situation is similar to the freezing point in chemistry, where a liquid transitions to a solid when the temperature drops to a certain level. Just as your productivity halts when your computer stops functioning, the movement of liquid molecules slows and eventually stops, locking them into a fixed position as they form a solid at the freezing point. The change of state from a solid directly to a gas. Sublimation. In simple terms, sublimation is when a solid becomes a gas without turning into a liquid first. Imagine you're watching ice cubes in your freezer slowly disappear over time, even though they haven't melted into water. This is similar to the process of sublimation, where a solid changes directly into a gas without becoming a liquid first. Just like the ice seemingly vanishes into thin air, sublimation involves a solid, like dry ice, transitioning directly into a gas, bypassing the liquid stage entirely, much like those disappearing ice cubes. An object's mass per unit volume. Density. Density is how much stuff is packed into a certain amount of space. Imagine trying to pack a suitcase for a week-long vacation, but it just won't close because it's too full. This is similar to the concept of density, where you're essentially trying to fit a certain mass of clothes within the limited volume of your suitcase. Just like how the suitcase's capacity is determined by how much you can pack inside it without exceeding its physical limits, an object's density is determined by how much mass it contains within a given space. A substance made of one type of atom that cannot be broken down chemically. An element is a basic building block of matter with unique properties. Imagine you have a jigsaw puzzle where every piece is exactly the same, making it impossible to break down into more basic parts. This is similar to an element, which is a substance made of one type of atom that cannot be broken down chemically into simpler substances. Just like the puzzle pieces that are all identical and form a complete image on their own, an element consists entirely of one kind of atom, which defines its unique properties and cannot be reduced further. The smallest particle of an element, atom. An atom is the basic unit of matter that makes up everything around us. Imagine trying to fix a jigsaw puzzle when you're missing just one tiny piece. Just like that missing piece is crucial to completing the entire picture, an atom is the tiniest part that makes up an element, essential for its identity. Each piece in a puzzle is unique and fits into a specific place, just as each type of atom has unique properties that define the element it composes. Without that one piece, or atom, the whole structure can't be complete or function properly. A particle with a positive charge in an atom's nucleus. Proton. A proton is a subatomic particle found in the nucleus of an atom that carries a positive electric charge. Imagine trying to organize a busy family gathering where everyone has different interests and personalities. In this scenario, the proton in an atom's nucleus is like the host of the gathering, maintaining a positive atmosphere to hold everyone together. Just as the host's positive energy keeps the diverse group from drifting apart and ensures that the event is harmonious, the proton's positive charge keeps negatively charged electrons orbiting around the nucleus, maintaining the structure of the atom. An uncharged particle in the nucleus of an atom, neutron. A neutron is a subatomic particle found in the nucleus of an atom that has no electrical charge. Imagine you're at a family gathering where everyone is having different conversations, and you're the person who neither argues nor takes sides, simply keeping the peace. Just like you in this scenario, a neutron stays neutral in the nucleus of an atom, not taking on any charge like protons, positive, or electrons, negative. In this analogy, the family gathering represents the nucleus. The different conversations are the interactions between charged particles, and you, remaining neutral, embody the role of the neutron, maintaining balance without contributing to the charge. A negatively charged particle outside the nucleus of an atom, electron. An electron is a tiny particle that orbits the nucleus of an atom and carries a negative charge. Imagine trying to keep a balloon from touching the floor by continuously tapping it to stay in the air. Just like the balloon that hovers around you without actually landing, an electron orbits around the nucleus of an atom, never quite touching it. The way the balloon is kept aloft by your taps is similar to how the electron remains in constant motion due to its negative charge, which keeps it attracted to, but not colliding with the positively charged nucleus. Much like the hovering balloon that stays up but never touches the ground. A group of atoms held together by bonds, molecule. A molecule is the smallest unit of a chemical compound that retains its chemical properties. Imagine trying to keep a group of friends together on a busy night out, ensuring no one gets lost in the crowd. Just like friends linking arms or holding hands to stay connected and not drift apart, atoms in a molecule are held together by bonds to maintain their structure. In this analogy, the friends represent atoms, the linked arms or hands symbolize the chemical bonds. And the effort to stay together in the bustling environment mirrors the stability provided by these bonds in a molecule. The center of an atom, nucleus. The nucleus is the tiny, dense core of an atom made up of protons and neutrons. Imagine trying to organize a chaotic closet where everything is scattered, and finding what you need is nearly impossible. Just like organizing your closet requires a central spot to anchor everything around, an atom's nucleus serves as the core structure that organizes the surrounding electrons. In this analogy, the nucleus is the neatly arranged center of the closet, like a sturdy shelf or a set of hooks, providing order and stability, while the electrons are similar to the items hanging or placed around it, ensuring everything stays in place and functions efficiently. A chart of all the elements arranged by their physical and chemical properties. Periodic table. The periodic table is a grid that organizes all known chemical elements by their properties and atomic number. Imagine trying to organize your closet, where you have clothes of different types, colors, and sizes. Just like you'd arrange shirts, pants, and dresses in separate sections for easy access, the periodic table organizes elements based on their similar properties and behaviors. In this analogy, each section of your closet represents a different group or family of elements, while the specific order within those sections reflects the increasing sizes or atomic numbers, making it easier to find or predict what you're looking for in both your closet and the world of chemistry. A combination of substances that keep their individual properties. Mixture. In science, a mixture is when different substances are combined, but each maintains its own properties. Imagine trying to organize a group of friends for a potluck dinner, where each person brings their own dish. Just like your friends each bring a unique dish to the table while maintaining their individual flavors, a mixture is a combination of substances that each retain their own properties. In this analogy, each friend represents a different substance, and their dishes are akin to the parts of a mixture, coming together to form a complete meal while still holding on to their unique tastes and characteristics. A mixture of evenly distributed substances. Solution. In science, a solution is a homogeneous mixture where one substance is completely dissolved in another. Imagine trying to bake a cake, but all the sugar is clumped in one corner of the batter, while the flour is in another. Just like how an uneven cake batter results in a lopsided and unappetizing cake, a mixture of evenly distributed substances ensures a consistent and desirable outcome. In both cases, whether you're baking a cake or creating a scientific mixture, the goal is to achieve uniformity so that every part of the mixture contributes equally to the desired result, ensuring that each bite of cake or each sample of the mixture has the same properties. A property of a substance we can observe without changing its identity, like color or hardness, is called a physical property. A physical property is a characteristic we can see or measure without altering what the substance is made of. Imagine you're trying to decide which book to read based solely on the cover design and title. Just as you can judge the book's cover and title without opening it to read the story inside, a physical property like color or hardness allows us to understand something about a substance without altering what it is at its core. In both cases, whether it's judging a book by its cover or determining a substance's color, you're making observations based on external characteristics that don't require changing the actual content or identity of what's being observed. A property that is not visible until a substance undergoes a chemical reaction, like solubility. Chemical property. A chemical property describes how a substance interacts with other substances, often resulting in a change in composition. Imagine you're trying to discover the flavor of a tea bag without actually brewing it. Just as you can't fully experience the taste of the tea until it's steeped in hot water, you can't observe certain chemical properties, like solubility, until a substance undergoes a chemical reaction. In both cases, whether it's the flavor of the tea or the solubility of a chemical, the true characteristic only reveals itself when the substance interacts with another medium. In one case, water, in the other, a reagent. The substance made when atoms from two or more elements combine chemically. Compound. A compound is a substance formed when different types of atoms bond together, like water being made of hydrogen and oxygen. Imagine trying to bake a cake with ingredients from your pantry. Just as flour, sugar, eggs, and butter combine to create something new and delicious when baked together, atoms from different elements combine to form a compound. In both scenarios, individual components, ingredients, or atoms come together to create a new entity with distinct properties, like a cake or a chemical compound, that is different from any of its individual parts. An element that is a good conductor of heat and electricity. Metal. Metals are substances that are typically shiny, dense, and can be molded, often allowing electricity and heat to move through them easily. Imagine trying to pass a message down a long line of people, where each person efficiently hears and quickly relays the message to the next. This is similar to how metals, as elements, conduct heat and electricity effectively, where particles within the metal quickly transfer energy to their neighbors. Just as the message travels faster when each person listens well and speaks clearly, metals conduct heat and electricity efficiently because their particles are tightly packed and free to move, allowing energy to be rapidly transmitted throughout. The gradual wearing away of a metal through chemical reactions. Corrosion is when metal slowly gets damaged and breaks down because of reactions with things like air or water. Imagine leaving a slice of bread out on the counter for too long, and it gradually becomes stale and moldy. Just like the bread breaking down because of exposure to air and environmental factors, metal corrodes over time due to chemical reactions with its surroundings. In this analogy, the bread represents the metal, and the staleness and mold represent the corrosion, both outcomes of their interactions with elements around them. The process of a gas changing into a liquid. Condensation. Condensation is when water vapor in the air cools down and turns back into droplets, like on a cold glass. Imagine trying to fit too many clothes into a small suitcase before a trip. As you pack, the clothes get compressed and squeezed tightly to fit into the limited space. Much like gas molecules cool down and come closer together to form a liquid. Just as the clothes change from a loose pile to a compact bundle in the suitcase, gas molecules transition from a freely moving state to a denser liquid form during condensation.